China can build factories, cities, and electric cars, but one tiny chip can still block its biggest ambition. A chip looks small, but inside it is the power of the entire digital economy. Phones, electric cars, robots, cameras, servers, and AI all depend on chips. Chips are no longer just electronic parts. They are economic power, data power, and strategic control. China has factories, a huge market, massive data flows, and powerful manufacturing capacity. But inside this giant machine, one bottleneck remains: advanced semiconductors. AI does not run on data alone. It needs computing power, and computing power needs chips. Without powerful chips, AI ambitions can slow down, even when data and talent are available. Modern chips are extremely difficult to make because they require microscopic precision. No country can easily build the entire advanced chip supply chain by itself. Advanced chips come from a global chain of design, software, tools, materials, manufacturing, and testing. Before a chip is manufactured, it must be designed with deep knowledge and specialized software. Design software is one of the most important gates in the semiconductor industry. After design comes the machinery that turns invisible plans into real circuits. Lithography is one key technology that prints tiny circuit patterns onto silicon wafers. Even materials matter, from wafers to chemicals and specialized gases. A chip fab must be extremely clean, precise, and incredibly expensive to operate. After manufacturing, chips must be packaged, tested, and verified before real use. If one critical link is locked, the entire technology chain can slow down. The United States does not need to block everything, it only needs to control key bottlenecks. Advanced AI chips are now among the most valuable assets in the technology race. The larger the data center, the greater the demand for powerful chips. In the new era, AI is like a factory and chips are the engines inside. China wants chip self-reliance because it does not want its future locked from the outside. Beijing is pouring money, policy, and attention into its domestic semiconductor ecosystem. Domestic companies are expected to become the pillars of China's chip ambitions. In manufacturing, China wants stronger foundries to reduce dependence on outside suppliers. Memory chips also matter, especially when AI needs to move data extremely fast. When the strongest chips are limited, engineers can optimize software and use weaker hardware more efficiently. Export controls can slow China down, but they can also push it to become more self-reliant. In the short term, China is constrained. In the long term, it has more reason to invest. But too much control can backfire by accelerating technological separation. Western chip companies also face the risk of losing access to a huge market. America's allies are pulled into the game because key chip technologies are spread across the world. Chip-making equipment has become one of the most sensitive parts of the conflict. A small country can hold a huge link when it controls a key technology. Ownership disputes show that chips are no longer just ordinary business assets. Taiwan is one of the most important links in advanced chip manufacturing. That is why chips are not just technology, they are geopolitical risk. The world is trying to rebuild supply chains to reduce risk. Some countries want more production inside networks of trusted partners. China is trying to build its own ecosystem outside the chain controlled by the West. If this continues, global technology could split into separate ecosystems. Rebuilding supply chains can make technology more expensive in the short term. The AI race makes the chip war more important than ever. The larger the AI model, the more chips and energy it needs. With hardware limits, China can focus on efficiency and smarter model design. Open models and software ecosystems can reduce some dependence on the most powerful chips. But no matter how smart the software becomes, hardware still defines speed and scale. Chips also matter for satellites, drones, radar, and modern command systems. Whoever controls chips gains an advantage in the digital economy of the future. The chip war is also a contest over who writes the rules of global technology. Scenario 1. China catches up faster than expected and builds its own chip ecosystem. Scenario 2. China stays strong in many industries but remains limited in high-end chips. The most realistic future may be mixed. Fast progress in some areas, wars in the hardest ones. The United States has major leverage, but technology control is not an easy victory. China is constrained, but it also has the resources and motivation to adapt. This conflict pulls the whole world in, from factories to governments and consumers. Consumers may feel the chip war through prices, product choices, and the speed of innovation. Businesses must adapt by finding new suppliers and spreading risk across more locations. AI startups are affected too, because compute has become a survival cost. In the chip chain, even small countries can hold very important links. Critical minerals have also become part of the technology competition. The tiny chip has become an economic, technological, and strategic tool. The big question is simple: who will control the foundation of future technology? China now stands between self-reliance, limited dependence, and a divided technology world. From AI to electric cars, from economy to security, chips now decide more than they appear to. A tiny chip can fit in your hand, but the war around it is shaping the future of the world.